Today we'll be working on AP Physics Concept 3.8.3.1. The student is able to analyze a scenario and make claims, develop arguments, justify assertions about the forces exerted on an object by other objects for different types of forces or components of forces. So the problem we'll be working on is a box slides down an inclined plane. The inclined angle is 37 degrees. Mass of the block, m, is 35 kilograms. Coefficient of kinetic friction between the box and the ramp is 0.3, and the length of the ramp itself, d, is 8 meters. Let's draw that out. Here's the incline, 37 degrees. Here's the box. So first, what we're going to have to do is identify the forces acting on this box. So of course we have force of gravity, because gravity is ever present and it's always pointing straight down. Then we have normal force, which is always perpendicular to the surface, and here's the surface, so Fn. And then of course there's friction pulling away from the direction the object is trying to go. So first, how much work is done by gravity? We know work is equal to force times distance. So first, recall that the force that's directly responsible for pulling the box on the plane is the component of gravitational force that's parallel to the ramp. So that would be this, which is this part right here, which is mg sine theta. And this part is mg cosine theta. So of course, w sine theta equals mg sine theta, where theta is the inclined angle. This component is parallel to the motion, so the work done by gravity, therefore, would be work by gravity equals mg sine theta times distance is equal to the mass, which is 35 kilograms, and then the force of gravity, which is 10 newtons by kilograms, times sine 37 degrees times the distance, 8 meters. And I pre-calculated this, and this will equal out to be 1690 joules. There you go. The next part of the question is how much work is done by the normal force. So this is actually pretty straightforward, because the normal force is perpendicular to the motion, so therefore the work done by this force is 0. So F of n is equal. That is, work done by the normal force is 0. Next, we'll tackle how much work is done by friction. So the strength of the normal force is force of gravity times cosine theta, as you can see from this diagram. So therefore the force of friction will be the coefficient of friction times the normal force. And this would basically be equal to the coefficient of friction times force of weight times cosine theta. Since the force of friction is anti-parallel to the distance, the cosine of the angle between these vectors is -1. So therefore the work done by friction is the negative force of friction times distance, since it's working against. And this would be negative kmg cosine theta times distance. We'd get 0.3 is 35 g is 10 newtons kilograms. Cosine 37 degrees, distance of 8 meters. Any questions? Okay, moving on. Once we plug all this in, we should get, and I have done this calculation beforehand to make things easier, negative 671. Part D, which is the total work done. Now this part is relatively simple, as work total is basically sum of all work. So far we have the work done by gravity. plus work done by normal force plus work done by friction. So by adding these, so we had here 1690 plus 0 from normal force, and we had negative 671 from friction. So total that up, that will be 1019 joules. There you go. That is 3.8.3.1 successfully demonstrated and completed. Yeah, there's supposed to be a negative sign. I made a mistake, put a plus sign.